First, we need to round to estimate the quotient. Then we need to calculate it using a calculator, or you can do it by hand if you really want to. And then we need to compare the estimate to our quotient. So if we are going to round 715, that is closer to 700 than it is to 800. And 11 is closer to 10 than to 20. From class, we learned that we can divide a 10 out. Then 1 goes into 7 times, and then we would have that 0. When we put this into our calculator, 715 divided by 11 comes out to 65. So this is a close estimate in number 2. 7,884 is closer to 8,000 than 7,000, and 12 is closer to 10 than it is to 20. Divide a 10 out. 1 goes into 8 times. There are no remainders, so then we need to use the zeros from below. If we were to type this into our calculator, 7,884 divided by 12 is 657. This is also a close estimate. If we were to estimate 9,646, we would say that is close to 10,000, and 13 is closer to 10. Divide out a set of 10, and 1 fits into that 1,000 times. The actual quotient is 742. This is a somewhat close estimate because 13 is kind of close to 10. For 11,942, we could say that's close to 12,000, or we could say it's close to 10,000 if we are rounding into the 10,000s place. Depending on if you're rounding to the thousands or the 10,000s, you may get a different answer. I am going to round it to 12,000, and 14 I'm going to round to 10. We can divide a 10 out, and we get an answer of 1,200 as our estimation. The quotient is 853. No, 853. And since 14 is not very close to a multiple of 10, like 10 or 20, this is not a close estimate. We can either round to the 10,000s and say that it is close to 50,000, or we can round to the 1,000s place and say that it is closer to 49,000. 15, you can say is either close to 10 or to 20, but typically we round 15 up, so we would have a 20. We can divide a 10 out. 2 goes into 4 twice, and then 2 goes into 9 4 times, which gives us 8, so we would have 1 left over. And 2 goes into 10 5 times. actual quotient is 3,255. This is a somewhat close estimate because we rounded to the thousandths place instead of the 10,000ths. But because 15 is 5 away from 20 and 5 away from 10, it isn't a very great estimate. On number 6, 135,296 is close to 140,000. And 16 is close to 20. We can divide a 10 out. 2 goes into 14 7 times with no leftovers. So our approximation is going to be 7,000, but our actual quotient is 8,456. I would say this is also a somewhat close estimate. We rounded 135 up to 140, but we also rounded the 16 up to 20, and so it kind of evened itself out a little bit there. And the 16 isn't as far away from 20 as 15 is, so this is a somewhat close estimate as well. For number 7, 199,988 is very close to 200,000. And 17 is close to 20. Divide out a set of 10. 2 goes into 2 once with nothing left over. So our estimate is 10,000. But the actual quotient is 11,764. I would say that this is a close estimate because it is close to 200,000 and 17 is close to 20. On number 8, 116,478 is close to 120,000, and 18 is close to 20. We can divide out a set of 10s. 2 fits into 12 6 times with nothing left over. So our approximation or our estimate is 6,000, but our actual quotient is 6,471. This is a close estimate too. And 116,000 is close to 120,000. So since these are both close to their multiples of 10, our quotient and our estimate come out close to each other. Now you're going to finish 9 and 10. You can decide if you are going to round to the thousandths, the 10,000ths, or the 100,000ths place for those first numbers. But then you're going to want to make sure that when you do the quotient, you actually use your calculator to find the answer, and then you need to compare for both of these. So you still have 2 left to do on your own, but you have 8 sample problems to do that you can follow along with and make sure you have the correct process.